Hello friends, so today we are going to learn the third important sections responsible for power on the laptops. In last two videos we seen adapter input and battery charging sections where the input voltage come from the adapters. So in this section we seen this input voltage coming from the adapters, okay, and this voltage is passed from adapter cross this two MOSFET coming here across this current sensing resistor. Suppose the voltage is 19, then coming across this 19 volt here, and then it pass and it goes output. Okay, so 19 volt goes output from here. Okay, and the next the 3 volt and 5 volt sections. So here is a 3 volt and 5 volt section. This 19 volt is coming from here and this voltage goes inside to the chips at its VIN pin. Here is a VIN pin. It's called the VIN pin. It goes inside the chips, this 3 volt and 5 volt chips, and then this 3 volt and 5 volt chip generate the 3 voltage. It is called VRG3, this pin, it's called the VRG3, and this volt coming out from this 3 volt and 5 volt chips, 3 volt, and it's this voltage is going to the SIO at its V standby pin. Okay, it's going to V standby pin. Okay, so this 3 volt coming from this 3 volt and 5 volt section, that is the linear voltage, and this linear voltage entered into the V standby pin. Wherever this pin is there are in some laptop there is a multiple pin, sometimes it is a 5 pin, 10 pin, whatever. So you have to go to the schematic diagram and check where is mentioned VSTBY, or sometime in the VCC. So there you have to check this 3 volt, and if it is the EC bias is there, then you have to check at pin number 8 if it is EC bias is there. But in the most of the modern laptops, like on the 4th generation onward laptop, there is a no EC bias. That means EC bias is there, but the EC bias is inside the SIO. That means the SIO is merged, the bias is merged into the SIO. So you have to check that. So what you have to do is you have to open the schematic diagram and you have to check this VTBY pin. You should get a 3 volt there, and this 3 volt linear coming to this pin. Okay, so that is step number 1. So the SIO get the power, SIO start working, but after that SIO need one more signal, and that signal is called the reset. SIO need the reset. So for that, here is a RC circuit. R means the resistor, C means the capacitor, is a series resistor, and series is connected into the series, and the 3 volt given to this resistor, and to charge this capacitor is required some delay, some time is required. So after the 3 volt given to the SIO, in a few milliseconds after, EC reset signal will generate. So that means this V standby get a 3 volt, and this ECRST also get a 3 volt in few milliseconds. So these are the step number 1 and then step number 2. Okay, and then if it is the EC bias is there, then this SIO start communicating with this EC bias. Here is a EC bias. Okay, so EC bias is normally 8 pin bias. Pin number 8 is a supply, pin number 1 is a chip select, pin number 2 is a read. At SIO start communicating with the EC bias. If it is the EC bias is there, if the EC bias is inside the SIO, that means after 4th generation, I already told you that the EC bias is merged into the SIO. So SIO start communicating with the bias, and after that SIO check the input signal and he check this lead switch. There also he should get a 3 volt at this lead switch pin. Okay, you will get a 3 volt, and then at AC in pin also, at this AC in pin also you will get a 3 volt. So you have to check V standby pin 3 volt, then you have to check EC reset 3 volt, then you have to check lead switch 3 volt and AC in 3 volt. Okay, so these are the voltage you should check if your laptop is not powering on the SIO. All this signal you have to check on the SIO. Okay. After that, SIO check, SIO wait to press the power button. There are two power buttons. One is called the input power button. This is the input power button, and this power button is called the NBS power on or KBC power button or on off switch or on off button, or it's called the NBSW on, like that. So these are the input pin where the 3 volt is there. When you press that power button, then the 3 volt goes to 0, and when you release the button, then it's come back to 3. That means the 303 variation will be there at this pin. So you have to connect a multimeter here, press the power button. At that time you will get a 303 pulse like this. Okay. So 303 pulse will be generated at this NBS on pin, and you'll get this DPWROK. In some laptop DPWROK signal appear before power on button. In some laptop the DPWROK generate after power button. So this signal also you have to check. Here also the 3 volt. And then after, what will happen is that SIO will turn on the buck converters. Like in previous video we seen how the 3 volt and 5 volt section work. In 3 volt and 5 volt section there are two linear supply, 3 VRG3 and VRG5, and this supply known as the linear voltage, and there is a buck converter also for 3 volt and 5 volt. So SIO get this linear voltage which is coming from 3 volt and 5 volt section, and now after the power button SIO send the enable signal to 3 volt and 5 volt section, and then or the 3 volt and 5 volt section turn on the buck converter, and that buck converter will generate the 3.3 volt always. It's called the always, and this voltage is going to the PCH. So now the PCH get the 3.3 volt. So this voltage is going to pin number VCC, DSW and SLPSUS. These are the two pins where PCH get the power. This voltage you can't check because here is a PCH is a BGA chip, so you can't check here, but you can check this voltage on the output of the buck converter. That means on the 3 volt and 5 volt section, at that output of that coil you can check this 3 volt there. If this 3 volt is coming, then this voltage is coming here also. You can assume that this voltage is coming at here also. Okay, so you will get a 3 volt, and after that SIO will generate the next signal, and that signal is called RSM RST. RSM RST signal will become a 3 volt. Okay, so once you press the power button, and then SIO, that RSM RST signal will be generated. Before power button, that RSM RST signal is 0 volt. After power button press, the RSM RST signal become a 3 volt, and if this 3 volt is coming at that SIO, that means our SIO is probably working. There is no issue on the SIO. SIO is okay. Now turn to PCH. Okay, now SIO send this resume and reset signal to the PCH. Now on the PCH side there are two three things you have to check. First, you should get this VCC DSW. Then here is the CMOS battery. Here is a CMOS battery, and that CMOS battery is a 3 volt, and this 3 volt is going to the RTC VCC. Here is a RTC VCC. Here is a dual diode. This is a dual diode. That means this 3 volt is coming VREG 3 pin. When we give the power to the laptop either from the battery or from the adapter, this linear voltage is going to this diode, and this diode sends this RTC VCC sections. When we remove all the powers, at that time our CMOS battery works, and the CMOS battery send RTC VCC to the PCH. Okay, so here also the 3 volt, and RTC sections require RTC reset. PCH is basically, PCH is a union of chips. That means there's so many chips inside in the PCH. Okay. And now there are only two sections are working. One is the RTC section and powered 3 volt from the RTC VCC, and another is a power management section. It's called the power management section. I write here MGNT. This is the power management section. Now the two sections are only working. So PCH got this RTC VCC 3 volt. Then PCH require one more signal, that is a reset signal. It's called the RTC reset. This is called the RTC reset. Here also a 3 volt should be generated. So here is the RTC VCC 3 volt, RTC reset is 3 volt, PCH is ready to work, and once we press that power button, the PCH get this VCC DSW. VCC DSW stand for VCC means the supply, and DSW means deep sleep wake up signal. DSW, deep sleep wake up signal, that 3.3, that PCH got the power to its power management department, and then SIO generate this RSM-RST. After RSM-RST, step number 7, SIO send a PM power button signal. This one signal, PM power button signal. Step number 7, SIO send this signal to the PCH, and this signal is called the PM power button, or in some model it's called the DNB WR on, or it's sometimes called a PBTN. So I'll write their name. In some laptop it's called a DNBSW on, sometimes it's called a PBTN, sometimes it's called a PM power button, BTN. So this one is signal, this one is that signal. Okay, and here also when you connect multimeter at that SIO at that PM power button, there you will get a 303 pulse will be generated. SIO send one pulse to the PCH, 303 pulse to the PCH, saying that the power button is pressed. Okay, so you have to check this signal by multimeter. So now the PCH will come to know that the power button is pressed. He'll get the information. Okay, and after that PCH has to reply to the PCH. PCH is a basically, here is a boss of the SIO. SIO is the assistant and PCH is a boss. Okay, now SIO requests PCH that the user press the power button. So now what I have to do? So PCH has to respond, PCH has to give the reply. Okay, and if everything is there, that means PCH got this power, PCH got this RTC reset, PCH started a clock, and then PCH got this DPWR. Okay, then the PCH send this two signal. This two signal is called, this signal is called PM underscore SLP underscore S3 and PM underscore SLP underscore S4. PM SLP S3 or SLP4. This signal PCH convert them into the 3 volt. This both signal are 0 volt, but once PCH get this input power button, then PCH will respond and convert both signal into 3 volt. That means you can check both the signal on the SIO at 3 volt. If this 3 volt come across this pin on the SLP3 and SLP4, 3 volt is there, that means PCH given the confirmations from there is a no problem from the PCH, and if this SLP S3 and SLP S4 signal remain 0 only, that means there is a no response. PCH send this request to the, SIO send this request to the PCH PM power button, but PCH is not responding, and if this both the signal remain a 0 only, that means probably problem in the PCH. So you have to replace the PCH, but before replacing you have to make sure 2-3 signal, 1 signal PCH should get VCC DSW, PCH should get RTC VCC, RTC reset, RSM RST, PM power button, DPW are okay. If all the signals going to the PCH probably, then PCH has to respond. If the PCH is not response, then in that case you have to replace the PCH. Okay, so remember. So this signal become a 3 volt. Okay, it's like this. It's become a 3 volt. That means the PCH give the confirmation to the SIO to turn on the motherboard, to turn on the all power of the motherboard. In laptop, there are two steps. One supply is called the standby supply that appear before power on button, and another supply is a power on when you press the power on button. In laptop motherboard, there are number of voltages are generated and different chips require different voltages. Okay, so if the laptop is DDR3 RAM, then the DDR3 RAM require a 1.5 voltage, then 0.75 voltage. Okay, 0.75 voltage. Then if the PCH is there, then PCH is require 1.05 voltage, then 1.8 voltage. CPU core requires CPU core voltage and graphics core voltage. So these are the voltages are required. Okay, there are number of buck converters are there on the motherboard, and this buck converter will turn on by the SIO one after another. It's not like he immediately turn on all the buck converter at one shot. He is going to turn on all the buck converter one after the another. So once he got the permission from the PCH, then SIO will generate the step number 9, and this signal is called system on, like this, and this system on become a 3 volt. That means SIO send this signal, system on signal, to that particular buck converter to turn on. Okay, so that particular buck converter, which is for the RAM supply, which will be turned on, I already told you that it's depend on RAM, it's depend on which DDR it is. If it is a DDR3, then 1.5. If it is the DDR3L, then 1.35. If it is a DDR4, then 1.2 volt. It's depend on DDR, which DDR it is. So you have to make sure that. So system on turn on the DDR supply, and then after SI will turn on the another signal, step number 10, and this signal is known as SUSP. So SI will generate, make it here a 3 volt, and is turn on this SUSP signal, and here its SUSP signal turn on 1.05 volt, 1.8 volt, and then 3.3 volt suspend, 5 volt suspend. All these voltages will be generated by this signal. Now all the voltages are ready, like 3.3, 1.5, 1.8, 1.05, 0.75, 5 volt, all voltages are there except CPU core and the graphics core. CPU is basically the king of the entire motherboard. So once all powers are stable, then SI will turn on this step number 11. This is called the CPU core, and for that SI will generate this VR on signal. Here is a VR on signal. Okay, that's step number 11. Okay, so SI will generate this VR on signal and turn on CPU core voltage, and here the core voltage will be turned on, and if it is a graphics core also there, then the graphics core voltage also turn on. The graphics core voltage is depend generation to generation. Some laptops doesn't require a graphics core voltage, in some laptops require a graphics core voltage. So it is depend generation to generation. So the CPU core voltage will be generated, and here is the CPU core voltage will be approximately 1 volt, because the in CPU core voltage there is considered a current. The CPU current is required approximately 30 ampere. Okay, so 30 ampere is required, where the new generation require a lesser current, the older generation laptop require a high current. Okay, So if it is a older generation like first generation, then it requires 30 ampere. If it is a second or third generation laptops require 20 ampere current. So the VR on signal generate the core voltage, and in this way your entire laptop will be turned on. So my dear friends, so I given a steps here, so it's very simple. I given here where is the steps, step number 1, step number 2, step number 3. So simply you have to follow all the steps. You have to open a schematic diagram and check all the signal which is mentioned here, and I'm sure 100% you can rectify the problem in the laptop motherboard. I hope you understand this video. Thank you very much for watching this video.